Hello Year 10 and welcome to the first lesson on surds. We're going to be looking at what is the difference between a rational and an irrational number and how can I simplify a surd. As usual, I'd like you to start with some recap questions. So first of all, recapping our last unit standard form, some simple percentages recap and looking back at unit 1.2 on estimating. Pause the video, have a go at those, and play when you're ready for the answers. Alright, hopefully you've had a good go at those. So first of all, we're converting from standard form to ordinary numbers here. 6.2 multiplied by 10 squared, or multiplied by 100, would be 620. 3.1 multiplied by 10 cubed, or 1000, or 10 three times, would be 3,100. 3.6 multiplied by 10 to the power of negative 5 is the same as dividing by 10 5 times, or the same as dividing by 100,000. 0.000036. Remember I told you the loop sort of test, let's see if you got it correct. So here 1 2, here 1 2 3, here 1 2 3 4 5, and then 5.2 divided by 10 twice would be 0.052. And again, you can do the little loop test, 1 2. If you're answering that, always rub your loops out afterwards, but they're just there to check if you've done that correctly. Okay, expressed in standard form. So this has been multiplied by 10 1, 2, 3, 4, 5, 6 times. So I've multiplied 1.7 by 10 6 times. Remember this number here can be equal to 1 or greater than 1 and has to be less than 10. 6.2 multiplied by 10 to the power of 1, 2, 3, 4. 6.3 multiplied by 10 to the power of, okay, now this is going to be a negative power because this number is less than 1. 1, 2, 3. Now the negative power here, 5.4 multiplied by 10 to the power of negative 4. Expressed in standard form. First of all, let's think, why aren't these numbers in standard form? Well, the reason is these numbers here are not between 1 and 10. So let's change this to 9.5. So I've divided this number by 10. So what I'll do with the 10 that I divided it by is I'll just move it over to here so it has the same value. So that will be 10 to the power of 7. The 10's still there, just moved it from 95 over to the power of 10. Here's 4.5 multiplied by 10 to the power of, oops, I can't see that. So it was 10 squared, so it will be 10 cubed because I'm going to move the 10 from here over to here. The next one, I'll say 5.1 multiplied by 10 to the power of 9. I moved 2 10s from here over to here. 7.9 multiplied by 10 to the power of, okay, so I've multiplied by 10 twice. So let's say that I've taken those 2 10s from over here. So I'm going to reduce these by 10 twice and multiply this by 10 twice. When I say reduce, I mean I'm going to divide this part by 10 twice and multiply by this part by 10 twice. Okay, 20% of 170, or 10% is 17. Multiply that by 2 to get 20%, that's 34. 80% is 400, 10% is 40, multiplied by 8 is 320. 40% is 840, well 10% is 84. Multiply that by 4. Double, it's 168. Double again, 336. 55%. Okay, so I'm going to do 10%, which is 34. Multiplied by 5, which gives me 170. 25%, which is 17. And then I'm going to do 170 plus 17, which is 187. Estimate. Remember, when we estimate, we round all of the figures to one significant figure. So 1.76 would be 2. 9,900 would be 10,000. And 825 would be 800. That's a 0 there. That would give us 20,000 divided by 800. Cancel out the zeros. Cancel, 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 cancel. 200 over 8 is the same as 100 over 4, which is 25. Okay, let's try that second question then. So 26.4 rounds to 30. 424 rounds to 400. And 23.6 rounds to 20. That gives me 12,000 over 20. Cancel out the zeros, and 1200 divided by 2 is 600. Here we go, there's our answers. Let's move on to the next part of the lesson. So, rational numbers. A rational number is a number which can be written in the form of m over n, where m and n are integers. Integers is another word for whole numbers. For example, 4 over 5 is a rational number. A rational number is in its simplest form if m and n have no common factor and n is positive. So in other words, if the fraction is fully simplified. Another example of a rational number, 4. Another example would be 1/2. 0.5 because it's the equivalent of 1/2. A million, 1,000, -2. All rational numbers. An irrational number, they're numbers which cannot be written in the form m over n, where m and n are integers. So examples of this are pi, the square root of 2, the square root of 3, the square root of 5. All irrational numbers, they cannot be written in this form. Right, you have a go at some questions. You decide if they're rational or irrational. If you want to, you can use your calculator. You pop the number in your calculator and then press the SD button, and then it will show you if it can be written as a fraction or not. Yeah, you guys have a go at this. Right, let's try these numbers then. The cube root of 6. So that's obviously not one of the cube numbers that we know. Let's just double check with our calculators. The cube root of 6 gives me this number. When I press SD, it's not converting it to a fraction for me. So the cube root of 6, that must be an irrational number. So that one's going to go in there. 3 over 8, well that's already written as m over n with integers as the numerator and the denominator. The square root of 6.25, well that's the same as the square root of 6 1/4, which if we convert that to a top-heavy fraction, 6 multiplied by 4 is 24, plus 1 is 25 over 4, and the square root of 25 over 4 is 5 over 2. So that's rational. Negative 4 is rational. Negative square root of 8. Well, 8 is not a square number, but we'll just start up on our calculator. Root 8. Okay. When you press SD, it doesn't give us a fraction, it gives us this decimal here. So that's irrational. Root 17. Again, 17 isn't a square number. We can't write that as a fraction. (1.4) recurring. Now there's a special method to write this as a fraction, which we will learn about later this year. Now, 1.4 recurring can be written as 13 over 9, so that is rational. Root 4 over 49 is the same as 2 over 7, so that's rational. And 0.3 can be written as 3 over 10, that's also rational. And 3 of those numbers were irrational. Okay, now moving on to a special type of irrational number, which is called a surd. A surd is a number that can be written exactly using square or cube roots. For example, root 3 and the cube root of 5 are surds. Root 4 and the cube root of 27 are not surds because the square root of 4 is 2, and the cube root of 27 is 3, so they are not surds. Let's go through and have a look at some examples. You think first of all if you think it's a surd or not, and then I'll tell you yes or no. Root 1. No. The square root of 1 is 1. Root 4. In fact, it's easier if I do this, because I can show you. Root 4 is 2. So that's not a surd. Root 9, not a surd, because we'd write that as 3. Root 25, not a surd. We'd write that as 5. Root 20, yes, that is a surd. We would simplify it to 2 root 5, which we'll learn how to do later in this lesson. That is a surd. We can't square root 20. Root 2, you can't square root 2. Well, you can square root 20, you can square root 2, but they don't give you a rational number. So we'll say yes, that is a surd. 2 root 2, yes, that's a surd. Root 2 is a surd. 2 root 1, no, because the square root of 1 is 1, and 2 multiplied by 1 is 2. 2 root 9, no, that's not a surd, because we would say 2 multiplied by 3, which is 6. 3 root 9, no, we'd say 3 multiplied by 3, which is 9. 3 root 3, yes, root 3 is a surd. If we square rooted 3, we wouldn't get an integer. 3 root 27, yes, that's a surd. If we square root of 27, we wouldn't get an integer because 27 isn't a square number. Now we're going to have a look at simplifying surds. Now, in order to do this, we really need to be confident in our square numbers. So for now, I'm going to write them down the side of the page, our square numbers. But of course, by this time, you really need to know them off by heart. Hopefully, you're saying these already. Hopefully, you already know them. Here are some of the square numbers that I'd expect you guys to know already. When we're simplifying thirds, we always look for factors that are square numbers. So root 60, let's go through. Yes, it has factor 1, looking for the highest factor that's a square number. Yes, it has factor 4. Not 9, not 16, no, 4 is the highest. So we would write that as root 4 root 15. 4 multiplied by 15 is 60. Root 4 multiplied by root 15 is root 60. Now only one of these numbers is a third. Which one? Root 15 is a third. Root 4 goes down to 2 root 15. Again, for root 120, we're going to look for a factor that's a square number, the highest factor. 4 goes in, 9 doesn't, 16 doesn't, 25 doesn't. 4 is the highest factor from this list that's a square number, so we'll say root 4 multiplied by root 30. Root 4 is the same as 2, and root 30, that's a third. So the answer is 2 root 30. You guys have a go at these ones. Okay, a square number that goes into 50. Not 4, not 9, not 16. Yes, 25 goes in. So we can say root 25 root 2. Root 25 multiplied by root 2 is 50. Square root of 25 is 5. And root 2 is a third. Root 200. 1 goes in, 4 goes in, 25 also goes in. Now we could say either root 4 multiplied by 50 or root 25 multiplied by 8. Or we could even say root 100 multiplied by 2. We always want to go for the highest. So we want to say root 100 multiplied by root 2, which gives us 10 root 2. Excuse me, which is in its simplest form. However, you may not have got that answer straight away. You may have done this, which gives you the same answer. Let's say you did root 25, root 8. You may have got 5 root 8. Now, that's not the correct answer, but if you've got that far, hopefully you continue to simplify, because you saw that root 8 has factor 4. So you could have done 5 root 4 root 2, because 4 multiplied by 2 is 8. The square root of 4 is 2. So that's 5 multiplied by 2 multiplied by root 2, which gives us 10 root 2, which is the same as the answer I had previously. This is obviously a more long-winded method. So you'd be better off looking for the highest square factor. Okay, let's try these ones. We have 2 root 20. Again, this list here is really helpful. If it helps, you can list them out every time. Hopefully you know them, but sometimes it's helpful to have them written there. So 2 root 20 is the same as 2. And the square number that goes into 20 is 4. Root 4. Root 5. The square root of 4 is 2. So we have 2 multiplied by 2 root 5, which is 4 root 5. The next question, 4 root 40. Again, 4 goes into 40. That's the highest square number that goes into 40. So we've got 4 root 4 root 10. Because root 4 multiplied by root 10 is root 40. So that's 4 multiplied by 2 root 10. Which is 8 root 10. Okay, you guys try these questions. Brilliant, hopefully you've had a go at those. 3 root 4 root 5 is 3 multiplied by 2 root 5, which is 6 root 5. 4 root 50 is 4 multiplied by root 25 multiplied by root 2. Oops. Let's try that again. 4 multiplied by root 25 multiplied by root 2, which is 4 multiplied by 5 root 2. 25 square roots of 5. Whoops, what's going on here? My mouse has got a life of its own. 4 multiplied by 5 multiplied by root 2, and that's 20 root 2. Great work, hopefully you got those things correct. If you haven't, go back and look at the examples again and try them again. Now let's have a look at some quick fire questions, and hopefully this will consolidate your learning there. Which of the following is not a third? The square root of 81 is 9. We can't square root, but we won't get a whole number if we square root these 3 numbers. So these 3 are thirds, and this one is not a third. Simplify root 50. So that would be root 25, root 2, which is 5 root 2. If you've got this answer or this answer, that's not correct, because 5 multiplied by root 10 isn't root 50. You could say root 5 multiplied by root 10, that would give you root 50, but there'd be no point doing this because you can't square root these numbers. Root 12, that would be root 4, root 3, which gives me 2 root 3. Root 48, that would give me root 16, root 3, which would be 4 root 3. Root 32, root 16, root 2, which would give me 4 root 2. Okay, let's just think if you ended up with answer B. Maybe you did root 4 root 8, which gives you 2 root 8, which wouldn't be the correct answer because you can simplify that further. You could then continue and say 2 root 4 root 2, which would be 2 multiplied by 2 root 2, which still gives us the answer of 4 root 2, but it's just a much more long-winded way to get to the answer. 3 root 8. Well, that would be 3 multiplied by root 4 root 2, which is 3 multiplied by 2 root 2, which is 6 root 2. So answer B. Great stuff. Work through these questions, starting on the left here and working down, and then down, and down, and down. Remember, really useful to write down your square numbers first so you can refer to those as you're working through. Pause the video, complete those questions, and then play the video when you're ready for the answers. There we go. If you made a mistake, just cross your answer, try it again until you do get to the correct answer. If you're making lots of mistakes and can't get the correct answer, maybe it's worth seeing your teacher or going back to look at the example again, or looking online for some more explanations. Okay, let's try these examples. 2 root 5 multiplied by root 6. Okay, so the coefficient here is 1, but we don't write it because we wouldn't write coefficient 1. 2 multiplied by 1 is 2. And then we've got root 5 multiplied by root 6. 2 multiplied by 1 is 2. And root 5 multiplied by root 6 is root 30. Here we have 3 multiplied by 2, which is 6. And root 3 multiplied by root 6, which is root 18. Now, be really careful here. Root 30 didn't have any factors that were squared numbers, whereas root 18 does. We could change that to root 9, root 2, which gives us 6 multiplied by 3 root 2, because the square root of 9 is 3, root 2 stays as root 2, which gives me 18 root 2. You guys have a go at this one, or these two should I say. Okay, hopefully you've tried those. 2 multiplied by 1 is 2. Root 5 multiplied by root 7 is root 35. And that doesn't simplify because there are no square numbers, apart from 1, that go into 35. 3 multiplied by 2 is 6. Root 3 multiplied by root 8 is root 24. Does that simplify? 4 goes into 24 and that's a square number, so we can do 6 root 4 root 6, which is the same as 6 multiplied by 2 root 6, which is the same as 12 root 6. Fantastic. Let's do some quick fire questions on those. What if you had root 3 multiplied by root 5? Well, that would give us root 15, which doesn't simplify because there are no factors that are square numbers apart from 1. 4 multiplied by 1 is 4. Root 3 multiplied by 6 is root 18. Is that the correct answer? No. We need to continue because we can simplify root 18 because it has a square factor which is 9. So we can say 4 root 9 root 2, which is the same as 4 multiplied by 3 root 2, which is 12 root 2. A, B, C or D, what do you think? Well, 2 multiplied by 3 is 6. Root 3 multiplied by root 7 is root 21. Right, some more questions for you to try. Have a go at these. Pause the video while you're working through and then play the video when you're ready for the solutions. There we go. Well done, everyone. Finally, for this part of the lesson, I'd like you to try these 4 questions. A little bit more problem solving, a bit more to think about. Once you've done them, I'll show you the answers, and then if you've made any mistakes, I'll go through the solutions slowly, so you can just go through the solutions to the ones that you need to. Right, let's go. Have you all finished? I'm about to show you the answers. Here are your answers. Now I'm going to take some time to go through the solutions to those questions. Square root of 7 over 4 is the same as root 7 over root 4, which is root 7 over 2. The square root of 5 over 9 is the same as root 5 over root 9, which is root 5 over 3. The square root of 12 over 49 is the same as root 12 over 7. And root 12 can be simplified to root 4 root 3 over 7 because the square root of 49 is 7. In fact, that's root 49, which gives us 2 root 3 over 7. Square root of 18 over 25 would be root 18 over root 25. Root 18 can be written as root 9 root 2. Root 25 is 5, so that's 3 root 2 over 5. Question 11. Solve the equation x squared minus 90 equals 0. Give me your answer as a third in its simplest form. So minus 90 equals 0. So in order to solve this, I'm going to use inverse operations. I've got minus 90, so I'm going to add 90 to both sides of the equations. And I'll get x squared equals 90. The inverse of squaring is square rooting. So I'm going to square root x squared and square root 90. Square root of x squared is x, and the square root of 90, and I'd say root 9 root 10, which is 3 root 10. Remember, when you square root, you get the positive and the negative solution. So that's plus or minus 3 root 10. Now for the discussion part, it says, can you solve the equation x squared plus 90 equals 0 in the same way? Let's try that here. X squared plus 90 equals 0. So the inverse this time is to subtract 90 from both sides. And then square root We can't solve that in the same way because you can't square root a negative number. Question 12. Solve these equations, give your answer as a third in its simplest form. 4x squared equals 200. Divide by 4. X squared equals 50. Square root x equals 5 root 2. 12b. Half x squared equals 80. Multiply by 2 to get rid of the half, or divide by half, which is the same as multiplying by 2. Square root. Remember, on the square root, we get the positive or negative solution. Okay, so 16 goes in. Root 16 multiplied by 10, plus or minus 4 root 10. Just going to go back over here. I forgot to do my plus and minus sign. You see, 3x squared equals 36. Divide by 3, x squared equals 12. Square root x equals plus or minus root 12, which can be simplified to 2 root 3. And then d, 2x squared minus 14 equals 42. Start by adding 14 to both sides. That will give us 56. Divide by 2, 28. Oops. Square root. And simplify if possible. X is equal to plus or minus 2 root 7. And finally, question 13. The area of a square is 60 centimetres. 60 square centimetres. Find the length of one side of the square. Give your answer as a third in its simplest form. So, the area of the square would be x multiplied by x, which is x squared, and that equals to 60. We know that the lengths are the same because it's a square, so we can call them both x. So to work out what one length is, we can square root 60. Now, of course, it would be a positive or negative, but because it's a length, we'll keep it as a positive. It wouldn't make sense for it to be a negative. And root 60, root 4, root 15, which would be 2 root 15. Okay, well done everyone. That was a totally new topic to you. Hopefully challenging enough, but not too challenging. And we have one more lesson on surds for this unit, and then we'll be learning about them again later on in the year.